Hi everybody, got a nice little demonstration for you to try to get you to appreciate how physicists and even other scientists can determine the values of, in this case, mass without being able to directly measure it. It's a very, very cool technique, and I'm going to use this PhET simulator to do that, looking at orbits. So let's say I want to measure the mass of this star. Let's say it's our sun. And we know that there's some physics going on with that star because something is orbiting it. So I'm going to play a little simulation that represents Earth. Okay, and it's actually to scale. So those little dots are so tiny because that's how big they are relative to each other. So we are on a planet, and it doesn't have to be our planet. It could be Mars, Mercury, Venus, whatever. But let's take our planet, and we know that it's orbiting it. And we know it's orbiting it because of this thing called gravity. Okay, so let's say you understand the force of gravity and how it relates to orbits. In fact, that's what Isaac Newton was able to do about 300 years ago. So we will learn that eventually in December. You don't have to know that now, but here's what I want us to understand. I want to figure out the mass of the star, but I can't possibly measure it directly. I can't even go there. It's not that easy. I'd burn up even if I could get there before I got too close. So what can I measure about the orbit? Well, hopefully you look at that. There's a number of things you might think of, but two stand out. You can see counting right up in this area right there is time. So we can measure something called the period. How much time does it take to go around once? That's not hard to measure. We've known that for a long, long time. The second thing about an orbit that defines the orbit is its distance from the object. So I could add, in this case, a tape measure going out, and obviously we can't do that in real life, but if I were to put this at the star and stretch it out to the orbit, I guess it's not working, that's all right, we don't have to do it, I can measure that distance. And in astronomy, that's not really hard to do. Okay, so we can measure two things about that orbit: how far away it is and how much time. So here on Smart Notes, I've simulated that. So we can measure r, that's the distance, and then we can measure the time it takes to go around t period. So if you understand the physics of gravity and how it relates to that, and again, we'll learn that, there is an equation that basically says if you take some universal constant, we'll call it little g, and you multiply it by the mass of the object, in this case the star, okay, and you divide it by r cubed, that's the distance cubed, that's going to equal 4 times pi. Where the heck did that come from? Well, that might be related to a circle, right? 4 pi r divided by t squared. Okay, again, we're going to learn that, but all these letters stand for. G is just some number that has to do with gravity. M is the mass of the star. That's what we're looking for. R is how far away the planet is. T is period, and pi is just a number. So if I solve algebraically for this, right, I can say the mass of the star, I cross multiply here. Well, this should be an r squared, not an r cubed. Anyway, I get 4 pi r squared times r is r cubed divided by t squared, and I'm going to divide the g out. And if you don't understand the algebra, that's not a big deal right now. But the point is, holy crap, if I measure the Earth's radius to the sun and its period, and I get it in certain conventional units, that in meters and in seconds, let's say, I can get the mass of the sun in kilograms. And we work that out, and it's roughly 10 to the 30th kilograms. And that's pretty powerful, because if we do the same thing with the sun as it orbits around our galaxy, right? So, you know, if I try to draw some spiral galaxy, well, let me see if I can get a new page here, right? So I mentioned this before, right? If this is a spiral galaxy, is just a bunch of stars that are orbiting a common center, right? We know in that center there's something called the supermassive black hole, but that's not really important. But if we say, okay, our sun is located out here, we can measure, at least astronomers can measure, the time it takes to go around the galaxy, a galactic year. I don't remember what that time is. I think it's like 100 million years or something. And we can measure the distance to the center of our galaxy. Not an easy measurement, but we've been able to do it over the last few decades. We can use that same equation and say the mass of the galaxy must be equal to 4 pi r cubed over gt squared. Okay, and that's pretty cool. All right, so make sure you answer the rest of the questions on the math sheet, and we're good to go.